knowing what the plumbing is, right, and how the execution is going to go, and understanding the implementation, as a child, I might say, okay, fine. I know that I'm going to go to my parent, and then my parent is going to come down to the child implementation, and I don't want to double count, right? And I'm going to, knowing that that's going to be the flow, I come back and I say, okay, fine, I won't count in the addAll because I know it'll come down to me again, right? And all the count will happen in my add, right? So I can now guarantee that that's not going to happen, and it works fine. I run my test, and my test now passes, right? That indeed they're only being counted once, right? So I'm all happy. We released the code. It's out in the wild, and and people are using it, and all our reporting on of our inventory is right. All our reports of graphs and whatnot are working perfectly. Every time they bleep something that comes into the warehouse, everything's being counted correctly, right? But one thing that we kind of skipped over was says, wait a minute, the decision of the child, right, not to double count was based on knowledge, first-hand knowledge that it had about the inner workings of the parent, right? The child had to know about what the parent was doing, right? And so it was breaking, some of the principles that we've been selling you as of information hiding, right? That every single class should be self-sufficient, right? And that it shouldn't have other classes have to know what's going on in the implementation internally. So why are we kind of allowing children to make some decisions about some implementations about the private inner workings of the parent? So let's look at an example of what could happen that a parent class, that might affect some of the decisions downstream from children that have already inherited from them, right? So, for instance, say a little later, okay, just a few months down the road, re-implementing our base classes, assuming that our implementation are self-contained, are hiding the information, nobody's depending on our internal data structures and whatnot, we might make a very sensible change to our implementation that is equivalent. As far as we're concerned, right, our implementation, our change here is going to be entirely equivalent to the way it was. For instance, we might say, I'm going to implement this. I'm no longer here in my addAll, right? Our base implementation. Instead of calling add directly from here, I'm just going to use the set.add, right? And notice that it's redundant, right? I'm calling set.add twice in the add and the addAll. Yes? Probably that was the original reason why one was calling the other. Yes? But for some reason, I come in here and I make a change, and instead of calling add, right, we actually apply the set.add. Notice that from our point of view, from this base implementation, these are entirely equivalent. Right? There's no problem here. Right? I'm not introducing any problem. My test from my class passed just the same. There's nothing wrong. I haven't broken anything as far as I'm concerned. Okay? But downstream, right? The tests for my children, they fail. They fail and says, wait a minute. My original test of passing 3 values and expecting 3, before it was over counting. It was double counting. This time it's not counting not even once. Right? I was expecting 3 and now 0. What happened? Right? So somehow nobody's counting now at anything. What happened? So that change that was very innocuous, change from the parent trickled down to the child. Right? Because the child had assumed certain things about the parent, right? Of how the plumbing of the inheritance works, right? So we'll need some parental guidance here on how is it that this inheritance should work, some plumbing. Perhaps indeed, parents should put some limits of what children can see and what things they have access to.